For Lesson 5-9, you'll be looking at similar figures, and you will be able to find the missing measures of similar figures and use scale factors to solve problems. Remember, the essential question for Chapter 5 is, how can you identify and represent proportional relationships? And once again, similar figures is another situation where you can use proportions to solve problems. On the middle of page 232, you have a key concept, and you have a model and some symbols to fill in on your note sheet. Please draw these two triangles, making note of the little lines indicating which angles are congruent and this corresponding angles are congruent. So if this one has 3 lines, that means angle Z is congruent to angle C because that one has 3 lines. And similarly, if Y has 2 lines there, that means it is congruent to angle B because there's 2 little lines there. So similar figures are figures that have the same shape but not necessarily the same size, and they are similar if these two conditions are met. The corresponding angles are congruent, which means they have the same measure, and the corresponding sides are proportional. And so we have a couple of symbols down here. This little triangle, that just means triangle ABC, ABC, and triangle XYZ are similar. So this is the symbol for similar. So please write that down in your notes. And then it also says that angle A is congruent. So here's your symbol for congruent, an equal sign with that little mark on top. And it goes through all of the angles that are congruent to one another. In addition, we say that AB over XY, AB, let me change colors here, AB over XY equals BC over YZ, BC over YZ, and then equals AC over XZ. So the corresponding sides, they're proportional, and those are opposite the corresponding angles. So make sure you get the model and the symbols into your notes for this lesson. And at the bottom, we have 2 different figures. We have figure ABCD, so this is a quadrilateral that's similar to EFGH. And then we can make those lines again saying that A is congruent to E. B, whoops, I'm sorry about that. I should not have put 2 lines there. A is congruent to E. B is congruent to F, and so forth. So down at the bottom here, A and E are corresponding, B and F, C and G, D and H. And then we also say their corresponding sides. AB corresponds to EF, and then BC to FG, and so forth. So just make sure you take some time to look at those images before trying the problems here. At the top of page 233, we have example 1 that says that since corresponding sides are proportional, you can use proportion or the scale factor that we did last lesson to determine the measures of sides when some of the measures are known. So again, if you have similar figures, same shape, not necessarily the same size, where the angles are congruent, so in this case, the angles are congruent, we can set up a proportion using the information that we do know to solve for something we don't know. In this case, we don't know the x. So we're going to make a proportion of what we do know to solve for that missing one. So come down here to the bottom of page 233, and I went ahead and set up a proportion for you. In 1a, we have the measure of 5 centimeters over 30 centimeters right here. That's where I have that. And then B over 24. Just so you know, I could have also done 5 over B equals 30 over 24. I could have also done 24 over b equals 30 over 5. There's several different ways to write these proportions. Just make sure that you're going in the same order on each of the figures. I would not want to do 5 over 24 because the 5 corresponds to the length and the 24 corresponds to the width. So just make sure that you're going in a logical order with these. No matter how you set these up, if I use this one, 30 divided by 6 is 5, so 24 divided by 6 is 4. Okay, if I wrote it as 5 over 30, I could reduce that to 1 over 6. So 6 times 4 is 24, and 1 times 4 is 4. And then even over here, I could reduce 30 over 5 to 6 over 1. And 6 times 4 is 24. 1 times 4 is 4. So for 1A, your answer should be 4 centimeters. 4B. And let's just try something just to show you here. If I did say 5 over 24, 5 over 24 equals b over 30. If I cross multiply and divide there and see what I get, five times 24 divided by 30. Oops. 5 times 24 divided by 30 also equals 4. All right, we're going to have to do some investigation on that because we're doing a length corresponding to the width here. So we do get the same answer, but I'm going to have to look into that one. For 1B, we have something that usually causes me problems because the figures are not in the same direction. And so sometimes I have to cut this out so I can get it in the same direction to figure out my proportion. But if you pay attention to the lines here, H and K are congruent, and then J and G are congruent, which is how I got the first ratio here. So 4 over A is where I got that. And then I need to find K to L. That corresponds to H to I. So then that's where I got the 7 over 14. Okay, again, when you cross multiply and divide, we were able to find that missing value. And so on 1B, the answer is 8. You could have also gotten that by reducing 7 over 14 to 1/2. 1 times 4 is 4, and 2 times 4 is 8. Either way you do that, the proportion, whether you're solving it mentally, using cross products, or using a calculator, you'll be able to get that answer. At the top of page 234, we have another example using scale factor, and we've used scale factors in the past. It's simply a ratio of a length on a scale drawing to the corresponding length of the real object. And it's also the ratio of corresponding sides in similar figures. And so in example 2, we are told that triangle ABC is similar to triangle DEF. So here's ABC in the drawing and DEF, and it says to find the segment DF given the information we know here. So we can plug those numbers into our proportion to find that missing length, cross multiply and divide to find that answer. In Got It 2, at the bottom of page 234, we have the length of the blue tile, which is 4.25, over the width of 6.75. Again, this is the length, this is the width, and I'm going to set a proportion using that last number we're given, which is a length of 12.75. So I'll put 12.75 with the length and then x for the width. We don't know the width. So again, when we cross multiply and divide, 6.75 times 12.75 divided by 4.25, we get 20.25 inches. Okay, it's not really a new concept using proportions to solve scale factors and using proportions to work with similar figures. So try these out on your homework assignment and then let me know if you have any questions.